What class was it?
All right. In Goal 8.3, we are learning our third method of solving a system of equations. Sometimes referred to as the elimination method, sometimes referred to as linear combination. They kind of both make sense because what you are doing is combining the lines together and trying to eliminate a variable. So both words or both ways of naming it make sense. I would say elimination method is probably the more commonly used one now, where it used to be linear combination. Okay. A couple things that you need to make sure of when you're using the elimination method, and that is that your x's and your y's and your equals and your constants are lined up. So x's with x's, y's with y's, equals equals, constants constants. It doesn't matter what side of equals they're on, but they should be on the same side. So you cannot use the elimination method when x is on one side in one equation and on the other side in the other equation. Okay, so make sure that they're lined up. That's really an important concept or an important component to this. Okay, your goal is to add the equations together and get a variable to drop out. There are 4 basic things that can happen. So I'm going to run through those 4 and then I'm going to talk about some special situations. Okay. So in this one here, I'll start with the easiest and get to the more complicated. When I add these 2 equations, everything's lined up, so I'm good to go. When I add the equations together, my y's are going to drop out. So I'm ready to go on this one. 5x plus 3x is 8x. Positive and negative y cancel each other out. 12 plus 4, 16. I'm going to solve for x. I'm going to divide by 8, and x is 2. To find the y value, you take your value that you got, in this case x, and I go back to one of my original equations, and I plug it in. So it's not as easy as the substitution plug-in, but it's very doable still. Okay, I'm going to go up to the bottom one. It doesn't matter though. So 3 times 2 plus y equals 4. And then I solve this. 6 plus y equals 4. Subtract. And y is a negative 2. So 2, negative 2 is my final answer. Again, this should work in both equations. I would check them. I would always check my answers if I had the opportunity to do that. Plug in 2 for x, negative 2 for y in both equations. Do they work? And if they do work in both, you know you're correct. It can't just work in one, it's got to work in both. Okay, second scenario. Again, your goal is to add the equations together and get a variable to drop out. Okay? In this particular example, my y's both have 16s on them. They're both positive at this point, though. If one of them were negative, then it would drop out. So that's what you do to change it. You take one of the equations, and it doesn't matter which one. I'll take the top one. And multiply it through with a negative. Giving me then positive 21x minus 16y equals positive 1. And then 33x, these are the same. I tend to be a person who rewrites things, so I don't miss signs and things like that. So that's how you're going to see me doing it. I didn't change the equation on the bottom at all. I took the top one times the negative. So now I'm ready to add down, and I get, this is a really bad question.
Please pardon this interruption. If the choir students could make their way to the music room right now, that would be fantastic. Thank you.
Sorry, 54x equals 20. I'm going to see if I need to change my
That's what I got.
I did it. So we're just going to go with it. You're good? Divide by 54. This is kind of an odd question. And I get 10 over 27. not a typical answer, so I must have a typo somewhere. But that's okay, we can go with it. It's not like it's not solvable, okay? So then we're going to plug this back into one of our expressions to get my value for y. I'll just go to the bottom one. So 33 times 10 over 27 plus 16y equals 19. So I'm going to multiply, and I get 330 over 27 plus 16y equals 19. I'm going to take everything times 27 to get rid of my fraction. This is not typical, just so you know. So I've got, canceling on the first one, 330 plus 27 times 16, 432y, wow, equals 27 times 19, 513. Subtract your 330. So I have 432y equals 183, and divide by 432. And I get a really bad decimal, so I'm going to go change that to a fraction. And I get y equals 61 over 144. Definitely a typo on my paper somewhere. But that's okay, we can still do it. Yes?
On that question, could you just subtract the bottom from the top and get the same thing? Does that work with all problems, like with 2?
Yep. Just watch your signs. That's all. And we're subtracting. Okay, on the third scenario, we can't just add because we'll get positive 10 and negative 4. X and Y would not drop. I can't just change the signs. That's not going to help because my coefficients are different from each other. So just changing the sign is not going to make something cancel out. So now you're going to multiply one of the equations by an integer. Let's use integers and not fractions so we don't get too stuck in making mistakes there. Okay. So I could take the bottom equation times a positive 2. That would make this 8. And then it would fall out with that negative 8. So I'm going to multiply the bottom equation by positive 2. I am not changing the top equation in any way. The bottom equation multiplied by through all the way through. Probably the biggest mistake that people make on questions like this is that they don't take it through to everything. They get this one and this one, but they don't do it times the constant. Okay? So now I'm going to add down, and I have 17x, my y's cancel, as I planned, negative 34, and divide, and x is a negative 2. And then again, I'm going to go back to one of the original questions, although you could go back to the one where you multiplied by 2. You could go back to that one. I go back to the original ones typically. I'm just going to go right to the bottom. So 7 times negative 2 plus 4y equals a negative 34. Negative 14 plus 4y is negative 34. Add 14, and 4y is negative 20, and divide, and y is a negative 5. And again, x, y coordinates, but if they do give you variables that are not x and y, it's alphabetical. Okay, question on that one. I think this is the easiest of the methods, honestly.
This one or the one to come? Like that one?
Like the method that, the elimination method, I think is the easiest method. Okay, and on my last one, first of all, things are not lined up, so I would be moving my 7 over. to make it 9x plus 10y equals a positive 7. So that my constants are lined up with my constants, okay? Now, when I look at this, I can't just add. I would get 15. I would get 18 on my y's. Can't just change the sign because my coefficients are different. I can't multiply 6 by an integer to get 9 or 8 to get 10. I could multiply it by a fraction, but let's not get too complicated here because it's much easier to work with integers. So this is where I'm going to multiply both equations by something to make a variable drop out. So you can pick x or y. I'm going to go with x. I have 6 and I have 9. So my least common multiple of those two numbers is 18. So I'm going to make them 18s. I'm going to make one of them a positive 18, and I'm going to make one of them a negative 18, so that they will fall out. It doesn't matter which one you make which. To make 618, I have to multiply by 3. To make 918, I'm going to multiply by 2. And make one negative. I'll take the top one, although it really doesn't matter. Or, as Jack asked earlier, you could make them positive and just subtract them. So then when I multiply through, I get negative 18x minus 24y equals negative 12. And on the bottom one, positive 18x plus 20y equals 14. And then I'm going to add, and I get negative 4y equals positive 2. Divide, and I do not get a half, I do not get 2, I get negative half. So you're dividing by negative 4, you're not dividing by 2. That's a more reasonable answer than that other fraction I had. And then I'm going to plug back into the beginning equation, one of them. I'll go to the top one, although it doesn't matter. So 6x plus 8 times the negative half equals 4. 6x minus 4 equals 4. 8 times negative half is minus 4. Add 4 to both sides. 6x equals 8. And divide, and x is in reduced form 4/3. And again, I would definitely check this. When you go to check it, it's easy to do because you just can punch it in your calculator. 6 times 4/3 plus 8 times the negative half, enter. Does it equal 4? Make sure you plug them into the original equations to check though. That's important. The original start of the question. Because once you start making transformations, like where I moved the 7 over, if you do that wrong, your answer is going to work in those, but it doesn't work in the original one then.